Hello, welcome back. I'm Jason with mathandscience.com. The title of this lesson is we're going to find the maximum and the minimum values of a parabola. This is part one. We also have a part two in this skill. So I'm very excited about teaching this lesson because probably the most interesting thing that I like doing when I teach these classes, and the fun thing for me, is explaining to you where things come from. So there's going to be a simple equation in here that I'm going to present that'll be in every algebra textbook that you have to learn, and it has to do with figuring out where the minimum value of the parabola is, or if it goes upside down, where the maximum value of that parabola is. It's usually just given to you and you memorize it and you use it, but you usually don't know where it comes from. So what we're going to do is introduce the concept of maximum minimum value of a parabola, which is not hard to understand. We're going to draw a couple pictures. I'm going to show you how to calculate the maximum and the minimum value of a parabola, whether it's in vertex form or if it's in standard form. And then if you stick with me to the end of the lesson, I'm going to actually show you where the equation comes from, which is more important than almost anything else, because these equations, they don't just fall out of thin air. They're very easy to understand if we just take just a few seconds to go through it. So let's first talk and go down memory lane when it comes to what a maximum and a minimum value is in a parabola. So first, let me give you a parabola in vertex form, because the goal of this lesson is to really talk about the max and min when we have either form, vertex form or standard form of a parabola. And by the way, if you don't know what vertex form of a parabola is, if you don't know what standard form is, then you need to go back to my previous lessons, because we've covered that extensively. All right, so we have a vertex form of a parabola. And the reason we like vertex form so much is because it makes graphing and understanding what the parabola looks like very, very simple. So here's an example, concrete example. Y minus 1 is equal to x minus 2 quantity squared. So this is a parabola. We know that it opens up. The reason it opens up is because the coefficient in front of the x term here, in front of the parentheses, is just a positive number. It's a positive 1. So we know it opens up, and we know it's the regular shape of an x squared parabola. Now we know this thing is not centered at the origin because of the 2 and the 1 here. We know it's shifted. So we can read the vertex directly off of this graph. That's why it's called the vertex form. And so the vertex, we've talked about all this stuff before. The vertex is 2 units shifted over in x and 1 unit shifted up in y. So the vertex of this parabola is at 2, 1. Also, as I said, because there's a 1 here, we know this parabola opens up. All right, we know that it opens up. So now what I want to do is take a break from that just a second and explain what I mean when I talk about the maximum value or the minimum value of a parabola. You can think of a parabola like a roller coaster. You know, it goes to the top and then it comes down. The maximum value is just what's at the very top there. If think of a roller coaster coming down like this, the minimum value is the value at the very bottom of the trough if it opens in that direction. So let's just draw a couple of images to make sure that we're all on the same page, so that when I tell you max min, maximum value, minimum value, you know exactly what I'm talking about. So for this parabola right here, I'm not going to graph it, but I know the vertex is 2 units to the right and 1 unit up. So the vertex is here, and I know that this one opens up. So this parabola opens up. So I'm just going to sketch it. This is not an exact graph at all, but you can see that it opens up. So why am I doing this? Because every parabola opens up like this, there's always a minimum value. So this is called a minimum value. So oftentimes in a lot of problems, the question will say, tell me the minimum value of the parabola. So in order for it to have a minimum value, it has to open up like that in order for there to be a bottom to it, right? There's no maximum value of this parabola because the parabola goes up forever and ever. It goes to infinity. So there is no maximum. The maximum is just infinity. But there is a minimum value, and it's right here. And we're going to talk more about that in just a second. Now let me draw the alternative. This guy opened up, so there is a minimum value here. But let me just kind of sketch another possibility. So this will be x and y, as always. And let's just draw a parabola over here. Here's a vertex, and this parabola might go upside down like this. So for parabolas that open down like this, they have what we call a maximum value. And that maximum value is right at the top. So you see, parabolas that open like this, they don't have any minimum value because the thing goes on down to negative infinity. They only have a maximum value. For parabolas that open like this, they don't have any maximum value. They only have a minimum value. So the very first step is, when a question says, tell me the maximum or minimum value, you have to figure out if the parabola opens up or if it opens down, because that's going to tell you if you have a maximum or if you have a minimum. You can't have a maximum and a minimum at the same time in any given parabola, because it's only going to open one direction. All right? So when you have the equation in vertex form like this, it's very easy to figure out what the maximum and minimum value of the parabola is, because it's all given to you by the vertex. Because in this case, the vertex of this parabola is right here, which was at 2, 1, right? 2, 1. And if I asked you, give me the maximum or the minimum value of this guy, you would just look on the graph and you would say, well, the minimum value is right here. But when I ask you what the minimum value is, what I'm asking you is, what is the lowest value in y that this thing really has? Now you can look at the vertex and you can see that this point is 2, 1, right? And so the lowest value in y that the thing gets to is just 1, because this is 1 right here, right? The x value doesn't matter. The x value is where the parabola is this direction. When I'm asking you for the minimum value or the maximum value, I'm asking you what value of y is, or how big or small can y be for this parabola. In this case, the minimum value is 1. So you can read it directly out of the vertex, but I want to show you something, because we're going to have to do this kind of thing when we solve our problems. All right? If you want to know the minimum value of this, I know it's given to you here, but you know where the vertex is, the x component of the vertex. The x component of the vertex is at 2. X is equal to 2. So I can take the value of 2 and stick it in here. Y minus 1 is 2, because that's the x value where the vertex is, minus 2 quantity squared. And I can solve for the value of y. So y minus 1 is equal to, this is 0 squared, so 0. So y is equal to 1. So you see, all I've done here is kind of silly, really. I've said, hey, the vertex is at 2, 1. So if I take, and I know that the vertex is at the bottom, right? So if I take the x value of the vertex and stick it in here, then I'm going to get the y value of the vertex, which is 1, which is exactly what the vertex is. So you can read it off. So you see, I've done a little bit of work, but I don't really need to, because when you are in vertex form, you already know the maximum or the minimum value. You just read it right off the vertex. And you do a little sketch to tell yourself if it's a maximum or a minimum value. All right, I had to go over that stuff because it's important to contrast it with what I'm going to talk about next. And that is, what if the parabola is not given to you in vertex form? And what if I give you a parabola in general form or standard form, and I ask you, what is the maximum or the minimum value of this parabola? Now, of course, you can take that parabola and you can convert it to vertex form. We actually did that in the last section lots and lots of times. So you could do that, but it's a lot of work. It turns out there's a pretty easy way to figure out the maximum or the minimum value of a parabola, even if it's not in this form. And that's what we're going to focus on. But I wanted to go through this first so you understand what maximum and minimum is and how you can read it directly off of the vertex form. But what if I give you a parabola? What if the parabola is given in this form? Let's see here. Y equals ax squared plus bx plus c. In other words, this is standard form, right? So if it's given to you in standard form, you can tell if it opens up or down. You can look at the coefficient. If it's positive, and the one in front of x squared, if it's positive, it'll open up. And if it's negative, it'll open down. But this doesn't really directly tell you, by just looking at it, what the vertex is, or if it has what maximum or minimum value there is. So a question typically will say, here is a parabola like this in this form. Tell me the maximum value of it. Now, you could convert that to vertex form, of course, and then you can read it off, but that's a lot of work. So what we're going to do is I'm going to present to you a rule or an equation to figure it out. And then we're going to solve a quick problem to show you how it works. And then at the end of it, I'm going to actually derive and show you where the equation comes from, which is not hard to understand. So stick with me to the end, and we'll get there. So if I give you an equation in this form like this, then there's a couple of choices, because it depends on if it opens up or opens down, right? So what we say is, if a is less than 0, then we say f of x, right? Which I put y here, right? But I could call it f of x, because everything's a function, right? So if this value of a is less than 0, then this function has a max value. And why does it have a max value? We'll do a little sketch right there, because if the thing has a negative value in front, we know it opens down. So it has to have a max value here at the top. There's no minimum value in that case. There's only a maximum value. Now the other case, you might guess, is if a is bigger than 0, a positive number, then f of x has a minimum value, right? Why does it have a minimum value? Because if this number here is bigger than 0, like if it's 3 or 4 or 5 halves or 1/2, anything bigger than 0, then we know the parabola opens up. So then the parabola looks like this, and that means that it always has a minimum value here. A minimum value. All right? So we know that if I give it to you in standard form, I can definitely figure out very easily if it's a maximum or a minimum value that we're dealing with. Now the next part of this little theorem is going to show you how to calculate that. So I can find the vertex. The vertex is located, and this is something we haven't learned before, is located at an x value of negative b over 2a. This should sort of look familiar because b over 2a, it's something that we run into before when we were doing completing the square. It's something we ran into before with the quadratic formula. You know, those kinds of, the quadratic formula is over 2a, you know, negative e plus or minus b squared minus 4ac over 2a. So we've run into like things with 2a on the bottom, but this is kind of different from all of that. This is an equation that tells you if I have this guy in standard form, I cannot read the vertex directly off of it, but I will prove it to you in a minute that the x value of that vertex is this quantity, negative b over 2a. So if this is, you know, 1, 2, and 3, then I would just stick the value in for b, the value in for a, I'd calculate it, that would be the x value of the vertex. Now before, like the vertex here is at 2, 1. If I were to calculate the x value of the vertex by this equation, I would be getting the first number here. This is the x value of the vertex. And if you remember, when you have the x value of the vertex, like we knew here, once we know the x value of the vertex, if you stick it into your equation for x, of course, then you're going to find the corresponding y value of the vertex, which is exactly what we did here. So once you know the x value of the vertex, then the y value of the vertex, or the y value of the vertex is, you can get it from here. You take this value of x and you stick it into the function, negative b over 2a. This stuff here is exactly what we did here. If you know the x value of the vertex, stick it into the function and you get the y value of the vertex. If you know the x value of the vertex, stick it into the function. That's what this means. I just stick that value of x in, and that's why I say f of negative b over 2a. What this means is I calculate the x value. Let's say for this I got a value of 2. That's the x value of the vertex. Then I just stick into the function a value of 2. And I calculate the corresponding y value, and you'll have a vertex in x, y. Once you have x, y for the vertex, you know what the minimum value is. Because here's the vertex here. The minimum value is 1 for this one. And so it'll basically be self-evident once you have the vertex. So this allows you to calculate the vertex of a parabola, even if you can't read it so easily from the parabola when it's in standard form. When it's in vertex form, you just read it directly off. You don't have to do any calculations. But here you have to do one little calculation. You get to find the x value, then you stick it in to the function, and you get the y value back. All right? And then from this, you find the maximum or minimum value. The minimum or maximum value is going to be the y value. So this is going to be the max or minimum value of parabola, because the y value is always the maximum or minimum value. So this whole thing kind of is its own theorem. And usually you will see this in books, and they'll just tell you, if you have a parabola, calculate the stuff, and you'll get a maximum or minimum value of it. Great, and you just do it. So what we're going to do now is solve a quick little problem. It's very simple. And then at the end of it, I'm going to show you where this comes from. And then you'll know not only how to use it, you'll know why we can do this. So you won't think it's black magic or something. Because I don't want you to think that. All right, so let's take a look at a real equation. Let's say I have a function, f of x. It's equal to 2x squared plus 8x. Now in this particular case, it's ax squared plus bx plus c, but there is no c. C is 0, basically. So what we really have in this situation, for this equation, is we know that a is 2, and we know that b is 8, and we know that c is 0, because it's not there, right? And so I go back to my theorem and I say, and I'm asking you the question, what is the minimum value of that function or the maximum value of that function? Well, what you do is you say, let me find the vertex. So to find the vertex, it's going to be negative b over 2a. I just calculated. So for the vertex, I go down here to find the vertex. I say this. I say the x value of the vertex is negative b over 2a. So b is 8, and a is 2, so it's 2 times 2 to a, right? And so I get, don't forget that negative sign, 8 over 4, which is negative 2. This is the x value. So the x value of the vertex is negative 2. So I label vertex. X value of the vertex is negative 2. All right? And just like we did before, when we had it over here, once we have the x value of the vertex, we can just plug it into the function for x and calculate the corresponding y value of the vertex. And by the way, that's exactly what this is saying. Take the value you get, stick it into the function to get the y value of the vertex. So let me switch colors and do that right now. And so in order to find the y value, it's going to be taking that function and evaluating it at negative 2. Why negative 2? Because that's the x value of the vertex. So I'll go back to my function and see what it is. It's 2x squared, but x is now negative 2. Don't forget to square it. Plus 8 times x, 8 of course evaluated at negative 2. And so what I'm going to get here is 2 times negative 2, when you square it, is going to be positive 4. And then here you have negative 16, so I'm going to erase this and make it a negative 16. And so what you have here is 8 minus 16. And so what you have here is negative 8. And so what you have here is, I wanted to write it over there. I'll put it right here. Y is equal to negative 8. So what you figured out from this is we've calculated the vertex. The vertex is located at an x value of negative 2 and a y value of negative 8. Negative 2 comma negative 8. All right, so if the question said, what is the vertex, I would just circle this as my answer. But the question says, usually for these problems, is what is the maximum or the minimum value of this function? Now, just knowing the vertex doesn't tell you that. Because remember, the vertex is going to be either at the top or the bottom of the parabola. The vertex is here or here. But in order to figure out if it's a maximum or a minimum value, you have to know, does the parabola open up or down? So the parabola has a coefficient of x squared of positive 2. That means that this parabola is going to open up. You know the vertex is at negative 2 right here, and then you have to go negative 1, 2, 3, 4, 5, 6, 7, 8. So it's way down here. And you know that it opens up. So basically you don't have to do all the sketching, but I'm showing you the vertex is down here, it opens up. So this is a minimum value. So this parabola has a minimum value, not a maximum value of negative 8. It's always the y value. You're looking for a minimum value in y. So this is what you would circle. The minimum value is negative 8. Or you would say the minimum value is y equals negative 8. You could also circle the vertex if it's asked or required as well. So now you can see the value of the vertex form of the equation is very, very even more powerful. Because now you can see that you can pull the vertex out, and from that you can figure out if it's in combination with if it opens up or down. You know if it's a maximum or a minimum value when you just read it directly off. If the equation is given to you in this form, with any coefficients at all, then I know if it opens up or down just by looking at it, by knowing the value of a, and I can calculate the vertex with these equations here. Basically, all you have to remember is this one, because once you have the x value, you just stick it into the function to calculate the y value, why it works, right? You stick it in there and you get the corresponding x comma y value of the vertex, right? Now what I want to do is focus on where does this come from, because I just threw it at you and I said, hey, that is a equation, enjoy it. But I want you to know where things come from. It's very easy to understand and actually build your algebra skills as well, because you have every bit of knowledge to understand that. So if I'm given a parabola in standard form, I'm always going to start with this. ax squared plus bx plus c. Now I have to keep it general like this because I have to keep it I have to do the proof for any value of any parabola. So I don't want to pick certain values. I'm going to leave it as A, B, and C because it could be any parabola anywhere in the plane, right? So what we're going to do is essentially convert this thing to vertex form as we have done in previous lessons, but we're going to do it with these variables. So we have to be careful. When there's numbers, it's easy to convert to vertex form. When there's variables there, or A, B, and C, I should say, placeholders for the constants, then you have to be a little bit more careful. But it's the same process we followed in the past. The first thing you do is you take the constant. We've done this before. You move it to the other side. So you say y minus c is ax squared plus bx. So far, so good. That's the first thing we did when we convert to vertex form. The next thing we did is we take a look over at the coefficient in front of x squared and make sure it's a 1. It's not a 1, it's a. So I don't know what a is. It's possible that a is 1, of course, but I have to keep it general. I don't know that a is 1, so I'm going to pretend that it's not. So in order to get rid of that, what I'm going to do is factor it out, which is what I have to do. So it's going to be x squared plus, now here's the tricky part. How do you factor out an a from this term? And a lot of students look at that and say, I can't do that because here's an a and here's a b. How do I factor it out? Well, when you start doing things, you kind of quote unquote grow up a little bit, right? And you start doing more proofs, you have to use and become very comfortable with fractions. It is true that it's basically looks like it's impossible to factor out an a from that. So you don't even think you can do it. However, look at how I can write this. I can write this as follows. I can write this as this term as b over a times x. And I'm going to close the parentheses. Make sure you understand what happened here. It doesn't look like you can factor it out. However, if I multiply back in, that's going to be ax squared. And if I multiply this in, it'll be a times b over a. But the a's would then cancel, and it would just leave bx, which is my term right here. So the truth is that you can't factor out numbers unless you kind of see the number there or a factor of it. But the truth is, I can factor anything I want because I can change the second term into a fraction so that when I multiply it back in, the cancellation gives me what I started with. That's all that matters when it comes to factoring, right? So when I multiply this times this, I get ax squared. When I multiply this times this, I get a times b over a. The a's cancel, giving me this. This little trick of leaving it as a fraction here is not really a trick. It's just making the backwards motion of the multiplication work is something that you will see as you get into more advanced math, okay? But it's not so hard to understand. It's just like a times b over a, and then you see the cancellation. Okay, so now we have a coefficient in front of this of 1. That's what we always wanted. Now we have to complete the square over here. Now it's ugly, right? Because the coefficient, remember, to complete the square, you look at the coefficient that's in front of x. Whatever the coefficient in front of x is, to complete the square, we've done it many times, you divide it by 2, then you square it, and then you add it to both sides. But the coefficient that's in front is a fraction, so it makes it tricky. So we're going to have to be careful, but that's okay. That's what we're going to do here. So we're going to say y minus c. I'm going to leave myself some space. I'm going to have a, and I'm going to have x squared plus b over a times x, and then I'm going to add a term to both sides, right? What am I going to add? I have to take the coefficient of x, which is going to be, I'm going to write it like this. I'm going to write it as b over a, right? But then I have to divide that coefficient by 2. And then I have to wrap parentheses around it, square it, and that whole thing is living inside of the parentheses. This is exactly the same thing as we've done every time we've completed the square. If the coefficient in front of x were 6, I would say 6 divided by 2 would be 3, square it, it would be 9. I wouldn't add 9 to both sides. But in this case, the coefficient is wrapped up in these b and a variable placeholders. So I have to leave it exact. I have to say, well, this thing's going to be divided by 2. And then one change I'm going to make is when you divide by 2, this 2 on the bottom can be written as 2 over 1. Now, what I'm going to do is you got to be a little careful when you add it to both sides. Remember, we did this in the past lessons on this. I can just add it to this side. However, I can't just, let me just start by saying that this whole term is multiplied by a. So when I added it to this side, I really added a times that. So to keep it balanced, I actually have to add a larger term over here. It's going to be a times b over a over 2 over 1 quantity squared, close the bracket. I add that to the left-hand side. Why did I multiply by a? Because when I added it to the right, when you multiply a in here, you're really adding a times this. That's the value you're adding. You're not just adding one of them, you're adding a times it to the right-hand side. So to balance it, I have to add a times it on the left. Now the truth is, I'm not going to continue simplifying this on the left because it doesn't matter. And you'll see why it doesn't matter in a second. So I'm going to say this is y minus blah, because I'm not going to go through simplifying all that stuff. You'll see why in a second. Over here, I can try to factor. Remember, completing the square, the goal of it is to factor. So it's going to be x times x to give me the x squared. And then over here, I think probably an easier way to do it. I should have probably done one more step. This thing right here reduces to the following. It reduces to, when you take the 2 over 1 and flip it upside down and multiply, it becomes b over 2a. That's where the b over 2a comes from. So b over a divided by 2, you can think of it as flipping over, multiplying it, so it's b over 2a. That's what this is squared. So that's what I've really added to both sides, and so that's what this term really is. And so when I come in here to do the factoring, see it's squared, so I'm going to call this b over 2a. And I think I'm going to, I'm going to leave it like that, b over 2a. And then, of course, there's a plus here, so I'm going to factor it like this. Now, I know it looks confusing, but just go backwards with me. X times x is x squared. The inside term is b over 2a times x, and then this is b over 2a times x. So you can think of it as 1/2 ba, 1/2 ba. You add them together, you just get a b over ax, which is what this is. Multiply the last terms together, you get the term that's squared. So this is the factored form of it. And so what I get is y minus blah. I'm not going to mess with that anymore. It doesn't matter. On the right-hand side, it's going to be x plus b over 2a quantity squared. Now, why do I care about that? Because the vertex form always looks like y minus blah is something x minus something squared. That's exactly what I've done. I've done the completing the square operation to take this quadratic and beat it into shape. So it's y minus blah something, and then x, of course I have a plus sign instead of a minus, a number. The number just happens to be b over 2a. So the x component of this vertex can be written from this equation. I don't care about the y value, I only care about finding the equation for that x value. The vertex has an x value. If this were a minus sign, x minus this, then it would be shifted to the right by that value, but it's a plus, so it's shifted to the left. So it's really an x value of negative b over 2a. Let me say that one more time. This is telling you the shift in the parabola in terms of x, right? How far over it's shifted. If it were a minus sign, it would be shifted to the right, and the vertex would have a positive sign there. But there's a plus sign, so it's shifted to the left. That's why where the negative comes from. So the vertex has an x value of negative b over 2a, which is exactly what we said in the theorem. So the theorem is just usually thrown at you, and it said, what if you have a standard form, ax squared, bx, and c? You can figure out if it goes up and down. The vertex has an x value of this. Once you calculate that, you stick it back into the function to find the y value of the vertex. Here I'm saying, where does that come from? Start from the standard form of a parabola and complete the square, which is what we've done when we've changed to vertex form. Move the c value over. Then I have to factor out that a, but then you have to know how to handle that. It has to be b over a so that the multiplication works. Then, since you have a coefficient of 1 there, you complete the square. It's this plus this, 1/2 of this coefficient squared. But when you take 1/2 of this coefficient, or divide it by 2 and square it, it becomes, when you flip over and multiply, b over 2a squared. And then you try to factor the right-hand side. The a is still here. This plus this and this plus this exactly comes back and gives you that factored form, which then can be written as this plus this b over 2a squared. And then the vertex is read directly from it. When you have x plus anything, the vertex is shifted left, and that's what it is. That's where it comes from. So in this lesson, we've introduced the concept of the maximum and minimum value of a parabola. And then we've also calculated the x value of the vertex of a parabola. And we've done a problem where, practically speaking, when we are given one of these parabolas, we can calculate the x value of the parabola. Once we know that x value, we just stick it back into the function to find the corresponding y value, and that y value is either going to be a maximum or a minimum value. In this problem, it was a minimum value because the thing opened upwards. But in another problem, if you had a parabola where it was opening down, then that vertex y value would be the maximum value. So make sure you understand where I'm coming from and that you can solve these problems and understand mostly the concepts of what's happening. Follow me on to the next lesson where we're going to do a few problems to get your skills going, and it's not going to be that hard. We don't ever have to do this completing the square business ever again. I just did that to show you where this equation comes from. The future problems are just going to calculate the x vertex, calculate the minimum maximum value, and then you're basically done with what the problem is asking for. So let's move on to that lesson and learn those skills right now.